All right, students, we're going to look at Module 7, Homework 3 now. So with Module 3, Module 7, Homework 3, we're now adding unlike fractions together. So in the last lesson, we ended with this question. We had it where we can simply combine the like terms in the numerator and then just combine them and simply add them and or subtract whatever we needed to do, right? Well, when we have a problem like this, we notice we don't have like fractions, and that's where it gets a little bit different in the strategy that you have to take. Now, the thing I want to say first before anything else is that you have to have representation of everything in the denominators, right? So I say it very particularly like that because this is represented and this is represented. Now notice how I go ahead and put parentheses around it. So when these are not like each other, like they were before when we were doing like fractions, right? Then what we can do is to make them like each other is simply cross multiply, all right? And then we can go ahead and multiply them together. That's when they're unlike each other like this. Now I'm giving you a shortcut way. So this is how you write it. All right, and then you put them together. You notice I see I have the arrows, and then I have to multiply to each other. Now, we've done that. We have common denominators now. That's basically why we're doing it. Okay, so now we could just go ahead and do the distributive property and combine like terms and isolate and all that. We do not need to go ahead and FOIL this through. That is, we leave it in factored form. Okay, so now I'm going to go ahead and get negative 4x plus 4 plus x plus 5, because 1 times anything in itself. And then now I'm going to combine these two together and get negative 3x, combine these two together and get 9, and then get x plus 5. All right, all right, and then x minus 1. I could factor out a 3 up here, but factoring out a negative 3 for that matter won't change anything. I'm going to lightly just write it up here and show you that it won't knock anything out. And that's what we want to make sure that we're watching for, is that we go ahead and check to see if we can't like cancel something out, when we're doing that. So since it doesn't factor out, we're going to go ahead and just leave it alone, and that would be our answer. So our answer is going to be the negative 3x plus 9 over this. Now watch, I'm going to go ahead and show you they'll accept that answer in factored form. Now where the answer that they gave right here is this foiled out, is how to do foiling. But watch, I'm going to prove to you that they will accept it in its factored form as well. So you're not like thinking I'm just lying to you. So we have plus 9, and then I'm going to put it in its factored form. And if it doesn't accept it, then hey, that tells me that okay, they don't accept it, but I'm pretty positive they do. So unless I type it in wrong. All right, and so I'm going to show you that this is submit the answer, and you see that they accept that as an answer, 1 of 1 point accepted. So I put it in factor form. Okay, now although that they give the answer in FOIL form, I personally prefer the denominator to be in factored form, and it keeps it easier for the students as well. So when you're answering these, you can put it in factored form. Now, when you're doing this one is again coming up with those common denominators, right? So if you had trouble doing this as a kid, you're probably going to find trouble still doing it until you get better at finding the common denominator, the LCD, least common denominator. But in this case, we're going to see it as 36, all right, because 9 times 4, I mean, it's 36. So the easy way of doing it is just simply multiplying them to each other like this. So this concept is pretty simple the way I'm showing you. I'm going to multiply that, it's 9, and then this is going to be positive 4r over 36. And then when we're doing that, okay, we have the ability to bring them together. Now, we can't factor anything out here, okay, and not a single value can go into each of those. So we just leave it as that as our answer. All right, it's pretty easy the way I'm showing you there. Now, I always tell you, you have to factor. You got to get these things in factor form. It would be nicer if they were in factor form, like where there's just a factor. These are not in factor form. It says find the LCD. All they want you to do is find the LCD between these two values in order to do this process. So we're not going to need to bring them together or anything. We just need to find the LCD. So what you need to do is you need to factor to reveal where they're the same, and then because they have representation on that, and where they're not the same, you're going to include that into your LCD. So I'm going to show you what I mean by that. So let's go ahead and factor them first. So the two numbers that multiply together to create 63 that adds up to 16 is what two numbers? All right, yes, you got it. It's 9 and 7, right? So we're going to go ahead and put 9 and 7, both of them being negative. And then we're going to go ahead and do what two numbers multiply together to create 72 to add up to 17. And we're thinking 8 times 9. Okay, yes, absolutely, 8 times 9. So we're going to get R, and then we're going to get 9, and then we're going to get R, and then 8. So now we look at these two values, and we see, I'm going to double underline it. We see that they're matching here. And now where they're matching there, I'm going to go ahead and combine these now as one denominator where I do not have this repeated. So I'm just simply going to write it as R minus 7, R minus 8, and then R minus 9. And it does not matter how I write this. I can write it like this. I can write it as the R minus 9 first. I can write it where the R minus 8 is first. It doesn't matter as long as I'm listing all of them. Okay, so that is the LCD. Now let's see what they listed it as. You know what? That is a miracle. I exactly listed it the way they did, which isn't common. I mean, it just depends on what side of the bed I wake up on how I write it. I don't even matter. So it would be the same answer. Okay. So finding the LCD is a very important process for when we factor to reveal where they are not the same is where we're going to cross multiply. That cross multiply thing that we did earlier here, we would be taking and multiplying by the component that they don't have. So I'll be multiplying this side by the R minus 8, and then I would be multiplying the other numerator by the R minus 7 because they don't have that in common to each other. So that's where the true fun begins, and that's what they're leading us towards. So we have to factor to reveal where commonality is present. Now, I have 3p squared. I got to come up with the LCD between these two. So I'm going to factor this one. And then I'm going to multiply that together. And that gives me this. And then I'm going to ask myself what two numbers multiply together to create -6. That adds up to 5. And that would be 6 and 1. And that would be -6, +1. Circle them. Put that over the leading coefficient. And then I would have to reduce it, and that gives me 2 over 1, and that's negative. So I'm going to get x, in this case, x is p. I love when they change up the variable. Okay, so it's p minus 2 times, and it's going to be, bottoms up strategy. That's the factoring technique I'm doing. So 3p plus 1. Now that I have this factored, okay, I got to factor the other one. So factoring the other one, I get 12p squared and then I'm going to go ahead and multiply them together. 12 and then I have 7. It's 5. Whoops, hold on. Sorry, 5. It's 3 and 4. And then I'm going to go ahead and put 3 over 12 and 4 over 12. And then I'm going to go ahead and reduce my fractions. That'll be 1/4 and 1/3. I'm going to have 4x. Oh, I did it again. All right, p, 4p. And then plus 1. And then 3p plus 1. I see that they're the same here. So my common denominator is going to be p plus 2, or minus 2, excuse me. And then 4p plus 1. And then the 3p plus 1. And that is my LCD. So let's see what they come up with. And it looks like, hey, I switched. See, that's why I say it's not very often do I nail it, but I didn't on this one. But you can see that I have the 4p plus 1 first, whereas they have it last. And so I just switched these two. So and you don't have to put the 1 in front of the p. That's kind of ridiculous that they did. But anyway, yeah, that's the LCD. Yeah, that's how this works. So we constantly working on finding LCDs on these. That's the ticketed item on how to make sure that works. All right. Now, when we're looking at this, we have the 5x minus 9. And then we have this. You know, this is seemingly a lot easier than what it looks like at first. And the reason why I say that, because these look very, very similar to each other, except for they have opposite signs. So why can't I just simply factor out a negative here and make them the same? So in other words, watch this. I factor out a negative sign, and I put that sign here, and I switch these around. I literally just switch their signs, and then they become this. Now I'm done with making them. Now they look exactly the same. They're common denominators. So all I got to do is switch the signs of this, and then 5x minus 7x is going to be negative 2x, and then I have plus 9 over x minus 3. So that is our answer that we're coming up with there. This one is a lot easier than most would think at first. They're not common yet. You make them common, and then you can bring them together like we did in the last lesson. All right, now in this one, all right, we're going to go ahead and have to factor. So here is the process. We've got to come up with a common denominator because they're not common right now. But let's go ahead and take a look at this and see that this is the difference of two squares. So when it's the difference of two squares, we have x plus 10, x minus 10, and we see that they're the same here. Well, they're the same there, but this one doesn't have the x minus 10. So what we do is we go ahead and multiply this to this. And since this already has the x plus 10, we don't need to go ahead and cross multiply it like we did in the last lecture. Okay? We don't have to because it already has it there. Okay? So we're going to go ahead and just multiply this times this and get 8x minus 80 plus x plus 170 all over our common denominator of x plus 10, x minus 10. So then all we have to do is go ahead and subtract 80 from that and get 90. So we're going to get this added together and get 9. And then we can factor out a 9 and get 9x plus 10 and literally knock this one off, leaving us with our answer, because I would have to rewrite this in order to do it, but I'm running out of room. As you can see, I can't write on the table. I'm going to go ahead and just shortcut it and say this is our answer. Okay, so I kind of cheated. I'm not cheated, but I failed to write it all down. I know some of you are like, you need to write down all the steps. All right, but I'm saving myself a little bit of writing, as I would hope that you would want to save yourself some writing. All right. Now, number 7. Now we're going to go ahead and see that we have, this is the difference of two squares. So we're going to have this. See, when you start getting good at this, you could see the light very quickly that the process is going to be very similar to each other, because now the difference of two squares is the factor form of this. We see that it's the same here, but this side right here lacks this guy right here. So what we do is multiply that to this. So we're going to get 6a, and then that a right there is going to multiply this a right here and get a squared, and then this a is going to multiply that 3 and get, I have a negative sign there, but it's positive. And then this 3 is going to multiply that a and get positive 3a. All over the a plus 3, a minus 3. Again, to reinforce, I do not need to multiply this to this side over here, 6a, because this has already been represented. Now, if you want to go ahead and look at it from a different perspective, if I go ahead and multiply this side by a plus 3, a plus 3 like this is multiplying by 1, isn't it? All right. And so what I'm doing is technically multiplying this fraction by a unique 1 in order so that the common denominators exist. That is what I'm doing, and that's probably what most other professors and what other instructors are going to teach, or books are going to show. So I have to support that idea, but I'm trying to give you a little shortcut for how to do this pretty quickly. Now we can see that we can factor out, or excuse me, not factor out, but we can bring this together, and we can factor out later, but we have a couple other additional steps we can do. We're going to get 9a, because that's brought together. Okay. And then I'm going to go ahead and get the plus, I'll put the a squared first. And then we have it as this. I love it when I change my variable on me. All right, so then I have this. So I'm just trying to copy down what I have here. So I have a squared plus 9a over this. Now I can factor in a, but that doesn't make any difference to me. It's not going to change my answer because I can't factor out a 3, for example, and make it become a plus 3 or a minus 3. So I'm going to leave it like that as my answer. All right. So that gives us the answer that we're looking for here. Now, this concept continues. Okay. So I have this. I'm going to factor, and you know what? Factoring is unique. I mean, I'm just going to tell you that most likely you're going to have w plus 3 as one of your factors. So I can already see that this is going to be 3 and 7, by the way, right away. And I know 3 and 7, 3 taken away from 7 is 4. So it's like, it's almost given, it's like a giveaway, I call it. So it's going to have to be the same thing. And excuse me. So I have the w plus 3 in there. So now the factored form of that, and not that that's a big deal. I mean, factoring, what two numbers multiply together create negative 21 to add up to negative 4, and that would be w plus 3, w minus 7. And then now these match, right? So we have these as our matchers. I always double underline my matchers. So what does this side have that this doesn't? And that is the w minus 7. And if you do like that concept of multiply by 1, you can go ahead and multiply top and bottom by this, or simply just go ahead and do what I've been doing the entire time, and that is multiply that together. And by the way, this is a -9. You see that negative sign? That goes to the 9. So it's going to be negative 9 W's. And then -9 times -7 is positive 63. All over. And then it's going to be the W plus 3, W minus 7. Now I bring these together. That's going to give me negative 8W plus 53 over, and then I'm tired of rewriting it, so I'm just going to be lazy and do that. I'm so lazy. I'm just rewriting it by simply putting an arrow and saying that's my answer. All right. But you should get the idea that all we're doing is combining like terms because we have common denominators. Now we go on to question number 9. We don't have to factor anything, so all we got to do is go ahead and cross multiply like we did earlier on some of those other problems. So because these are not exact or the same at all, what we'll do is go ahead and multiply this to this, multiply this to this, and multiply them together. This little kind of picture should be ingrained in your head a little bit, because now we gotta we can write it just for the sake of writing it. We can write it like this, so that way we can FOIL out our process a little bit cleaner. But this is what we have. And then we're all going to put that over the r plus 5 times r plus 7. So you get the idea of where the arrows go to each other, and then you have them joined together in the denominator. So now it's just a matter of FOIL to bring all like terms together and then simplify, right? So now, FOILing this, we're going to get r squared. You know, when you have simple trinomial or simple binomials like this and multiplying, all you got to do is multiply these together and get squared, add these together and get positive 4x, and then go ahead and multiply them together. That's how simple that is. And then I'm going to go ahead and do the same thing over here. I'm going to go ahead and multiply these together, add these two together, put it with it. Oh, I love variables, man. They should have make every one of these just x's, because I put x's for everything. So now I got that, and then I add these together. I add these together and multiply them together. Excuse me. Now I go ahead and don't even touch the bottom, by the way. Don't ever FOIL the bottom. Okay, now I'll bring everything together. I get this together. That gives me 2r squared. Bring these together. That gives me 13 r's. And then bring these together, and that gives me -1. And then I'm going to go ahead and leave that as my answer because I'm being super lazy, and I don't even feel like trying to factor that to see if it's even factorable. All right. And I got the answer. So yes, I was being lazy, but I kind of already saw that the answer wasn't factorable to a point where it reduces down to r plus 5, r plus 7. So I didn't care. So you see how I'm kind of basically doing the cross multiplying and multiplying the numerators together, or the denominators together. That's the process I want you to guys get ingrained into your head. It always starts with factoring first. So this process continues. Now, because my students in here want me to go over every single question, you're probably going to find that this is repetitive. And it is, because they're trying to get you to practice. Okay? So practice is good, and so you have different experiences. So the process here is that I factored first, multiply this to this. That gives me this as the same, right? And then I have this times that, and that gives me plus m squared. Excuse me. Yeah, m squared. And then I have plus 8m. M. Over the denominator, which is now this. And then I'm going to go ahead and combine. I can't combine anything, so I can rewrite this as just simply the m squared plus 8m plus 8. I'd rather write it that way. Okay. Now you're probably saying to yourself, well, oh my gosh, what's going on here? Why is it the M16? Because it probably, let me double check. All right, that's what I did. I have this right here. I forgot to put the M in there, and that's a transcription error. So then that's why I have 8 plus 8 is 16M. So I apologize about that. My bad. I have a transcription error. There's nothing wrong about what I did. Okay. It seems like this is redundancy, and it is. I don't have to do this again. I'm gonna go ahead and default and say I'm not gonna do number 11 this time, because this 11 is just like this question right here that I just did. It's just slightly different letters and different numbers, but it's the same exact kind of problem. So I'm going to go ahead and defer that you can be able to do that for yourself. I'll default it to my class that I'm currently teaching this to determine for the rest of the classes moving forward. Does anybody need me to do that again? Now, see, I'm letting my students tell me whether or not they need me to do it. So does anybody need me to do that again? Please respond. Because otherwise I'm going to move on. Okay, my class is replying no. So I'm going to go ahead and default that students be able to do number 11 for themselves. Okay, number 12. All right, so I'm going to go ahead and see that I have this. This is not much different from any of the others as well, is that I'm simply taking and multiplying it out like this. That's as far as I'm going to go with it, because I've already given great detailed and instruction on that process as well. So I'm going to say that this hasn't changed either. Okay, so now I'm moving on to question number 13, see if there's anything worth talking about. Here we have 7 over x plus 5 minus 16. And then I'm going to factor out the x. And because I factor out the x, it reveals that these are the same. So all I got to do is multiply this to this. My answer would simply just be 7x minus 16 over this right here. So that's the answer we're looking for there. All right, this moves very quick. All right, now some of them move faster, obviously, than others. Now I have this 7 here. Now, when I have that, I know that this is over 1. So I need them to have the common denominator. So simply all I got to do is multiply this to this, and then just put that over top of the on the numerator. So I'm going to go ahead and put 8p plus 9, and then it's going to be 49p minus 21 all over 7p minus 3. And then I would combine like terms and then simplify if I can. Apologize that my book was off the screen. So 8 plus 49 gives us this 57p, and then 9 minus 21 gives the negative 12. There's nothing that I'm teaching that's different than what I've already taught you on that, except for you didn't understand that the 7 probably was over 1, and that all you had to do is multiply cross multiply the numerator by the denominator that was over here. So that was what was unique in that one, and that's why I processed that. The way I'm doing this is very structured, and that's why I love that you're watching this video to help you see the simplicity of it and get through it, because it's not complicated. Here we have where we could, there's like things that you can factor, like for example, you could factor out a 2 in this right here, but I'm not going to do that right now. I'm just going to leave it as it is. I'm going to factor the denominator, and I'm going to get x minus 5x plus 3. I'm going to factor out a negative 1 from x, or 5 minus x, and that's this strategy that I have to go ahead and realize that this is the same thing as a part over here, and I changed that negative sign to a plus sign and made it like that. So now these are the same. I'm going to go ahead and multiply this to this. All right, because these are the same. All I got to do is multiply this to this, and then I'm practically done. So I'm going to go ahead and do that. So I'm going to get x squared plus 3x. I'm going to put that all over the 5, or the x minus 5, x plus 3. And then I'm going to combine like terms. So I'm going to get x squared. I'll write it over here. I'll write it over here. X squared. And then I'm going to combine these two together and get positive 11x minus 10 all over this common denominator. All right, so we have that. And that's my answer. Why did I put a negative sign? Because I made a mistake on transcription. And yep, there's the transcription error. Gotta love transcription errors. That happens, even to the best of us. Okay, and that concludes adding and subtracting of unlike denominators.